Nature and Wonder, a Reconnaissance of Heaven. By far the best way I know to engage the religious sensibility, the sense of awe, is to look up on a clear night. I believe that it's very difficult to know who we are until we understand where and when we are. I think everyone in every culture has felt a sense of awe and wonder looking at the sky. This is reflected throughout the world in both science and religion. Here are two images of the universe. For obvious reasons, they concentrate not on the spaces in which there is nothing, but on the locales in which there is something. It would be very dull if I simply showed you image after image of darkness. But I stress that the universe is mainly made of nothing, that something is the exception. Nothing is the rule. That darkness is a commonplace. It is light that is the rarity. As between darkness and light, I am unhesitatingly on the side of light. But we must remember that the universe is an almost complete and impenetrable darkness, and the sparse sources of light, the stars, are far beyond our present ability to create or control. This prevalence of darkness, both factually and metaphorically, is worth contemplating before setting out on such an exploration. This image is intended for orientation. It is an artist's impression of the solar system, in which the sizes of the objects, but not their relative distances, are to scale. And you can see that there are 4 large bodies other than the Sun, and the rest is debris. We live on the 3rd piece of debris from the Sun, a tiny world of rock and metal with a thin patina, a veneer, of organic matter on the surface, a tiny fraction of which we happen to constitute. This picture was made by Thomas Wright of Durham, who published an extraordinary book in 1750, which he quite properly called An Original Theory or New Hypothesis of the Universe. Wright was, among other things, an architect and a draftsman. This picture conveys a remarkable sense, for the first time, of looking at the solar system and beyond to scale. What you can see here is the Sun, and to scale to the size of the Sun is the distance to the orbit of Mercury, then the planets Venus, Earth, Mars, Jupiter, and Saturn. The other planets were not known in his time. And then, in a wonderful attempt, here is the solar system, the planets we talked about, all in that central dot, and a rosette to represent the cometary orbits known in his time. He did not go very far beyond the present orbit of Pluto. And then he imagined, a large distance away, the nearest star then known, Sirius, around which he did not quite have the courage to put another rosette of cometary orbits. But there was the clear sense that our system and the systems of other stars were similar. Here at the upper left is the first of 4 modern illustrations attempting to show just the same thing, in which we see the Earth on its orbit and the other inner planets. Each little dot is intended to represent a fraction of the plethora of small worlds called asteroids. Beyond them is the orbit of Jupiter, and the distance from the Earth to the Sun, represented by the scale bar up at the top, is called an astronomical unit. This is the first introduction. There will be many of them that I will talk about, of a kind of geocentric or anthropocentric arrogance, with which all of the human attempts to look at the cosmos seem to be infected. The idea that an astronomical unit, by which we measure the universe, has to do with the Earth's distance from the Sun, is clearly a human pretension. But since it is deeply embedded in astronomy, I will continue to use the word. At upper right, we see that the previous picture is wrapped in a small square in the middle. Here we have a scale of 10 astronomical units. We cannot make out the orbits of the inner planets, including the Earth, on this scale, but we can see the orbits of the giant planets Jupiter, Saturn, Uranus, Neptune, as well as Pluto. At lower right, the previous picture is in a small square, and we now have a scale of 100 astronomical units. Here's a comet, there are many, with a highly eccentric orbit. Another increase in scale by a factor of 10, and we have the picture at lower left. And here the gray shading is intended to represent the inner boundaries of the Oort Cloud of roughly 1 trillion comets, cometary nuclei, that surround the Sun and extend to the boundaries of interstellar space. This is an artist's representation of the entire Oort Cloud. Now the dimension is 100,000 astronomical units, and there is an external boundary to the Oort Cloud. All of the planets and the comets that we know are lost in the glare of light from the Sun. And here, for the first time, we have a scale sufficient to see some of the neighboring stars. So the world that we live on is a tiny and insignificant part of a vast collection of worlds, many of which are much smaller, a few of which are much larger. The total number of such worlds are, as I said, something of the order of 1 trillion, or 10 to the 12, a 1 followed by 12 zeros, of which Earth represents just 1, all in the family of the Sun. And our star, of course, is one of a vast multitude. Here Thomas Wright has made a leap or two, and now we see more than one system with a cometary rosette. He clearly had the sense of the sky being full of systems, more or less like our own, and was as explicit in words as he is here in a picture in his 1750 book, which, by the way, is also the first explicit statement anywhere that the stars we see in the night sky are part of a concentration of stars that we now call the Milky Way galaxy, one with a specific shape and a specific center. There are a vast number of stars within our galaxy. The number is not so large as the number of cometary nuclei around the Sun, but is nevertheless hardly modest. It's about 400 billion stars, of which the Sun is one. This is the Pleiades, a set of young stars that have been born only recently, and are still enveloped in their cocoons of interstellar gas and dust. This is one of the many nebulae, large clouds of interstellar gas and dust. Just to be clear what we are seeing here, there is a sprinkling of foreground stars, behind which is a cloud of glowing interstellar hydrogen. That's the red stuff. The darkness is not the absence of stars. It is simply a place where the dark material prevents you from seeing the stars behind. It is in dense concentrations of this dark interstellar material that new stars and, we are now beginning to see, new planetary systems are in the process of being born. This is a photograph of a dying star. In the course of its evolution, it has expelled its outer layers in a kind of bubble of expanding gas, mainly hydrogen. Stars do this episodically, possibly periodically, and when they do, grave problems are posed for any planets that are around such a star. This is hardly an unusual event for a star a little more massive than the Sun. Here's a still more explosive and dangerous event. This is the Veil Nebula. It's a supernova remnant, a star that has violently exploded, and any life on any planet that existed around the star that exploded, the supernova, would surely have been destroyed in this explosion. Even ordinary stars like the Sun have a sequence of events late in their history, which mean big trouble for the inhabitants of any planets that they might have. Some 5 or 6 or 7 billion years from now, the Sun will become a red giant star and will engulf the orbits of Mercury and Venus and probably the Earth. The Earth then would be inside the Sun, and some of the problems that face us on this particular day will appear, by comparison, modest. On the other hand, since it's 5,000 or more million years away, it is not our most pressing problem. But it's something to bear in mind. It has theological implications. There are a huge number of stars, especially in the center of the galaxy in the direction of the constellation Sagittarius. The sky is rippling with suns. Altogether, a couple of 100,000 million suns, making up the Milky Way galaxy. As far as we can tell, the average star is in no major way different from the Sun. Or, put another way, the Sun is a reasonably typical star in the Milky Way galaxy, nothing to call our attention to it. If you had stepped a little back and included the Sun in this picture, you would not be able to tell whether it was that one right there or that one right over there maybe, in the top right-hand corner. It would be very good to have a photograph of the Milky Way galaxy taken from an appropriate distance, but we have not yet sent cameras to that distance, and so the best we can do for now is to show a photograph of a galaxy like our own, and this is, in fact, the nearest spiral galaxy like our own, M31, in the constellation Andromeda. And again, we are looking at stars in the foreground within the Milky Way galaxy, through which we are seeing M31 and two of its satellite galaxies. Now imagine that this is our galaxy. We are looking at a great concentration of stars in the center, so close together that we cannot make out individual ones. We see these spiral lanes of dark gas and dust in which star formation is mainly occurring. If this were the Milky Way galaxy, where would the sun be? Would it be in the center of the galaxy where things are clearly important, or at least well lit? The answer is no. We would be somewhere out in the galactic boondocks, the extreme suburbs, where the action isn't. We are situated in a very unremarkable, unprepossessing location in this great Milky Way galaxy. But, of course, it is not the only galaxy. There are many galaxies. A very large number of galaxies. This image is meant to convey just a little sense of how many. We are looking out of the plane of the Milky Way galaxy in the direction of the Hercules cluster. What we are seeing here are more galaxies beyond the Milky Way. In fact, there are more galaxies in the universe than stars within the Milky Way galaxy. Here we see some foreground stars, as in the previous picture, but most of the objects you see here are galaxies, spiral ones seen edge-on, elliptical galaxies, and other forms. The number of external galaxies beyond the Milky Way is at least in the thousands of millions and perhaps in the hundreds of thousands of millions, each of which contains a number of stars more or less comparable to that in our own galaxy. So if you multiply out how many stars that means, it's some number, 10 to the... something like 1 followed by 23 zeros, of which our sun is but 1. It's a useful calibration of our place in the universe, and this vast number of worlds, the enormous scale of the universe, in my view, has been taken into account, even superficially, in virtually no religion, and especially no Western religions. Now, I've not shown you images of our own tiny world, nor did Thomas Wright. He wrote, "To what you have said about my having left out my own habitation in my scheme of the universe, having traveled so far into infinity as but to lose sight of the earth, I think I may justly answer as Aristotle did when Alexander, looking over a map of the world, inquired of him for the city of Macedon. 'Tis said the philosopher told the prince that the place he sought was much too small to be there taken notice of, and was not, without sufficient reason, omitted. The system of the sun," Wright goes on, "compared with a very minute part of the visible creation, takes up so small a portion of the known universe that in a very finite view of the immensity of space, I judged the seat of the earth to be of very little consequence." This perspective provides a kind of calibration of where we are. I don't think it should be too discouraging. It's the reality of the universe we live in. Many religions have attempted to make statues of their gods very large, and the idea, I suppose, is to make us feel small. But if that's their purpose, they can keep their paltry icons. We need only look up if we wish to feel small. It's after an exercise such as this that many people conclude that the religious sensibility is inevitable. Edward Young in the 18th century said, "An undevout astronomer is mad," from which I suppose it is essential that we all declare our devotion, at risk of being adjudged mad. But devotion to what? All that we've seen is something of a vast and intricate and lovely universe. There is no particular theological conclusion that comes out of an exercise such as the one we've just gone through. What's more, when we understand something of the astronomical dynamics, the evolution of worlds, we recognize that worlds are born and worlds die. They have lifetimes, just as humans do, and therefore that there is a great deal of suffering and death in the cosmos, if there is a great deal of life. For example, we've talked about stars in the late stages of their evolution. We've talked about supernova explosions. There are much vaster explosions. There are explosions at the centers of galaxies from what are called quasars. There are other explosions, maybe small quasars. In fact, the Milky Way galaxy itself has had a set of explosions from its center some 30,000 light-years away. And if, as I will speculate later, life and perhaps even intelligence is a cosmic commonplace, then it must follow that there is massive destruction, obliteration of whole planets that routinely occurs, frequently, throughout the universe. Well, that's a different view than the traditional Western sense of a deity carefully taking pains to promote the well-being of intelligent creatures. It's a very different sort of conclusion that modern astronomy suggests. There's a passage from Tennyson that comes to mind. I found him in the shining of the stars. I marked him in the flowering of his fields. So far, pretty ordinary. But, Tennyson goes on, in his ways with men, I find him not. Why is all around us here, as if some lesser god had made the world, but had not force to shape it as he would? To me personally, the first line, I found him in the shining of the stars, is not entirely apparent. It depends on who the him is, but surely there is a message in the heavens that the finiteness, not just of life, but of whole worlds, in fact of whole galaxies, is a bit antithetical to the conventional theological views in the West, although not in the East. And this then suggests a broader conclusion, and that's the idea of an immortal creator. By definition, as Andrian has pointed out, an immortal creator is a cruel god because he, never having to face the fear of death, creates innumerable creatures who do. Why should he do that? If he's omniscient, he could be kinder and create immortals secure from the danger of death. He sets about creating a universe in which at least many parts of it, and perhaps the universe as a whole, dies. And in many myths, the one possibility the gods are most anxious about is that humans will discover some secret of immortality, or even, as in the myth of the Tower of Babel, for example, attempt to stride the high heavens. There's a clear imperative in Western religion that humans must remain small and mortal creatures. Why? It's a little bit like the rich imposing poverty on the poor and then asking to be loved because of it. And there are other challenges to the conventional religions from even the most casual look at the sort of cosmos I've presented to you. Let me read you a passage from Thomas Paine from The Age of Reason. Paine was an Englishman who played a major role in both the American and French revolutions. From whence, Paine asks, from whence then could arise the solitary and strange conceit that the Almighty, who had millions of worlds equally dependent on his protection, should quit the care of all the rest and come to die in our world because, they say, one man and one woman ate an apple? And on the other hand, are we to suppose that every world in the boundless creation had an Eve, an apple, a serpent, and a Redeemer? Paine is saying that we have a theology that is earth-centered and involves a tiny piece of space. And when we step back, when we attain a broader cosmic perspective, some of it seems very small in scale. And in fact, a general problem with much of Western theology, in my view, is that the God portrayed is too small. It's a God of a tiny world and not a God of a galaxy, much less of a universe. Now we can say, well, that's just because the right words weren't available back when the first Jewish or Christian or Islamic holy books were written. But clearly that's not the problem. It's certainly possible in the beautiful metaphors in these books to describe something like the galaxy and the universe, and it isn't there. It's a God of one small world, a problem I believe that theologians have not adequately addressed. I don't propose that it's a virtue to revel in our limitations, but it's important to understand how much we don't know. There's an enormous amount we don't know. There's a tiny amount that we do. But what we do understand brings us face to face with an awesome cosmos that's simply different from the cosmos of our pious ancestors. Does trying to understand the universe at all betray a lack of humility? I believe it's true that humility is the only just response in a confrontation with the universe, but not a humility that prevents us from seeking the nature of the universe we're admiring. If we seek that nature, then love can be informed by truth instead of being based on ignorance or self-deception. If a creator God exists, would he or she or it or whatever the appropriate pronoun is, prefer a kind of sodden blockhead who worships while understanding nothing? Or would he prefer his votaries to admire the real universe in all its intricacy? I would suggest that science is, at least in part, informed worship. My deeply held belief is that if a God of anything like the traditional sort exists, then our curiosity and intelligence are provided by such a God. We would be unappreciative of those gifts if we suppressed our passion to explore the universe and ourselves. On the other hand, if such a traditional God does not exist, then our curiosity and our intelligence are the essential tools for managing our survival in an extremely dangerous time. In either case, the enterprise of knowledge is consistent surely with science. It should be with religion, and it is essential for the welfare of the human species.